My name is Kelly Pampel, Technical Manager for Invino Engineering. We're a domestic and international engineering firm focused on steam and condensate systems. Today I want to talk about what really increases or decreases boiler efficiency, which is part 2 of a 2-part series. Radiation or thermal losses on insulated associated piping. As you see in the left-hand picture, thermal losses off of piping that's not insulated, and I don't quite understand why people don't insulate the piping. It's a pretty significant loss. As you can see in the middle picture is a flue gas section uninsulated going to the economizer. Again, pretty significant loss, probably costing somewhere $30,000 a year. And the other thing is that we typically in the steam systems on smaller plants use firetube boilers, which back wall has high temperatures. High temperatures up to 300 plus degrees. If you do the calculations, average size of a firetube boiler, 500 horsepower, and boilers costing anywhere from $30,000 to $60,000 a year because of the radiation losses. The other thing to keep in mind, OSHA says anything over 140 degrees, you have to protect plant personnel from burns. So the other thing is a safety issue. So, solutions, possible action items or solutions. Boiler selection, select boilers with a lower outside wall temperatures. These boilers here shown in the pictures, a recent project that we did. You can touch an outside wall of any of these boilers and you will not get burnt. I mean, they're insulated well. Insulate everything. As you can see down the left-hand side of the pictures, the deaerator is insulated and covered. The piping is insulated and covered, for protection. So the insulation doesn't get abused or blowdown. The thing with blowdown, the surface and bottom blowdown, losses can range from 0.5% to 12%. Action item, proactive program and recovering all condensate. More condensate you have coming back, less blowdown you're going to have. Condensate's pure. It's the purest water you're going to have for the boiler. Purer than RO. So higher condensate recovery means lower blowdown. So if you are blowing down for the reasons there, make sure you're doing blowdown heat recovery. Deaerator operation, non-condensable vent, feed water temperature, and deaerator operation. Non-condensable vent, dissolved oxygen testing, 7 parts per billion. You need to be doing testing every 3 months, or most people are going to online testing. You need to do the test per ASME standards. So, reduce steam venting depending on the dissolved oxygen test. So, if I'm down at 1 ppb, parts per 7 parts, 1 part per billion, then I'll reduce the vent to atmosphere. The deaerator manufacturer in their specification will have the quantity of venting that's required. So typically it's 100 to 250 pounds per hour. Very small to get the non-condensable gases to come out of the deaerator. Pressurized condensate directly back into the deaerator. Don't stop at a condensate tank vented to atmosphere. So if we have high pressure deaerator, we can take that directly back into the deaerator without deaeration. End user for flash steam recovery. Take the flash steam from the it's coming back into the system and utilize it for the deaerator operation on, let's say, a pressurized return system. So you increase the steam thermal cycle efficiency. The real thing we want to be looking at is steam system thermal cycle efficiency, and that's not boiler efficiency. 1 pound of condensate loss equals 1 pound of makeup. So if I am out there discharging condensate to the drain, 1 pound of condensate means I'm going to make up 1 pound of makeup water. Now that can increase my blowdown. Besides, increases my chemical costs. It contributes to energy losses. So makeup water and trace mineral will have to be removed from the boiler operation or blowdown. So the last thing I want to be doing is adding makeup. But, that's why we need to bring condensate back to the boiler plant. And we don't want to be venting steam to atmosphere. Steam venting is the number one energy loss. It's a loss of condensate besides loss of energy. 1 pound of steam being vented is 1 pound of water. Today, there's no reason for steam venting in today's industrial plant operation. There's not. You should never be venting steam. So, example, flow rate of 2,411 pounds per hour, energy cost of $3.08 per 1,000. This event here is costing you $62,394 a year. Sizable. Emissions, CO2 emissions, 327 pounds per hour. CO2 emissions per year, 2,871,500 pounds per year. Which is extremely sizable. So today, no more venting. Stop venting steam to atmosphere. Action items provide steam venting. Pressurized condensate return systems are awesome. Cascade systems are tremendous. And you can also implement thermal compressor systems or even implement vent condensers. Anything but vent steam to atmosphere. What happens on Monday? So, the thing is going to come to the plant. We're going to look at all vents to atmosphere and set a roadmap for correcting the venting so that in a year and a half, there's no more steam vents to atmosphere. We're going to run dissolved oxygen testing on the deaerator every 3 months and adjust the vent for the non-condensable gases to make sure we're optimal venting and we're not excessively venting steam, which we don't want. So there's a number of action items that we can do, and it begins on Monday. So at our website, we have 70 best practices, 28 articles, and 24 instruction videos. Come up and review the best practices at www.indenoeng.com. We continue to update and add to our library at all times, and we also have the technical papers, which you see on the right-hand side, covering 70 different topics, and we're adding more topics all the time. Partnerships with our clients. We have short-term impact, steam system engineering assessment, steam system balancing, steam system reliability, steam system engineering training. Long-term, implementation engineering, project design, project management, full engineering support for steam system changes. We can help you in any possible way with steam and condensate. My contact information. If you have any questions regarding steam, condensate, or boiler operation, contact me at my email address that's located here. And visit our website, which is also located. We're here to be part of your team and help you optimize your steam and condensate system, specifically your boiler operation. Have a great day. Thank you.